Hello, this is Alexandros Valantasis. I'm a research engineer at Intracom Telecom, and today I will present our work, the ph platform and OSM for security analytics automation in network slicing. This work has been developed with my colleagues, Nikos Psaromanolakis and Vasileios Theodorou, and is also an offspring of our research activities in a collaborative Horizon 2020 research project, the 5GZORRO, which provides several novel concepts and breakthroughs for especially zero-touch security and trust for 5G evolution networks. Let's see the basic concepts of an overview of our presentation. First of all, we have our motivation. Next, we will present our π-Edge platform for edge computing automation. Also, we will show a workflow of how OSM requests network slices enriched with security service at the edge. And finally, we will show a demo. First of all, in previous ecosystem, we had present our π-Edge platform, which is a PaaS-based edge management platform that offers edge automation services and capabilities, and is also interoperable with centralized orchestrators such as OSM in a declarative fashion. In this work, we focus on the declarative security services that are translated automatically in a zero-touch manner by the π-Edge platform into enhancements and configurations that foster the trust, the reliability, and the robustness of the network slices. Here we can see a high-level architecture of the π-Edge platform. As you can observe, we have the π-Edge platform that consists of a plethora of components, but in our case, we will emphasize only to the security services, declarative API gateway, and the edge catalog. Also, we have our system manager that communicates with the π-Edge platform and also with a centralized NFV Mano, which is, in our case, the OSM, that also is responsible for the cloud core domain. One core component of the π-Edge platform are the edge catalog. The edge catalog contains the service function, the PaaS services, and the edge nodes. The service functions are the smallest units of our deployment, which can be containers, pods, or virtual machines. And also, the service function will describe the behavior of our deployment. On the other hand, we have the PaaS services that consist is a chain of services that are connected. So, as you can see at the picture at the right, we have a PaaS service named Support Security Services, and also includes two connected service functions, the Elasticsearch and Kibana. Last but not least, we have the edge nodes that represent the supported edge nodes of the edge cluster. So, another core component of the π-Edge platform are the security services. There are two kinds of security services, the core security services and the support security services. The core security services are integral components of the π-Edge, and there are the declarative security API gateway that receive requests for activating or deactivating a secure slice, and a security actuator and observer that has the main responsibilities to configure the slice VNF, the routing rules, or to enable security analysis, and also to be informed about the security status of its slice. On the other hand, we have the support security services that are acting as agents because they are deployed on the edge host, where they are shared among the different network slices that they are instantiated to the same host. The security support services includes two service functions, functions that are connected, the search and analytics engine, and also the monitoring and interactive visualization application. As you can observe, here we present a high-level NST descriptor where we provide information about the security automation service, such as the ID, the type, the name, while also the actuation policy to be applied when a specific threat is detected. In addition, as you can see at the picture, we have our initial slice where the network slice VNFs are included, where this slice is automatically extended and enriched with additional VNFs, the dedicated security services, which are the security analysis service and the virtual router. The security analysis service are responsible for supervising the slice, continuously analyzing traffic and checks for weird or malicious activity per slice, is connected to search and analytics engine, which is a support service, decides when the slice should be characterized as trusted or not, and also acts to the slice when needed. Also, we have a virtual router that connects the slice VNF and forwards the traffic to the security analysis service for further analysis. Now we'll show a flow of how OSM requests a network slice enriched with security services at the edge. At the right, we can see the system manager on top of OSM. Also, we have the Edge platform, the OpenStack, and at the left, we can see the Edge host. As you can observe, the π-Edge platform had already deployed the security support services, which is a shared services, to the Edge host. The first step, we onboard the NST with the NSD and a VNFD with the SAS field true to the system manager. The system manager automatically extend this network slice enriched with security analysis service and a BIOS, and send it to OSM. The OSM orders these virtual resources to the OpenStack. The OpenStack deploy this extended slice to the Edge host. Also, the system manager informs the π-Edge platform in order to configure the VNFs. So, the security actuator and observer connect the two VNFs through the BIOS and also activate the security analysis service and connect it to the supported services. In addition, enable a specific threat identification behavior. Now, what happens when the security analysis service identify a suspicious traffic pattern? First of all, inform about suspicious traffic the security actuator, and then perform a specific action. In our case, this action is to change the granularity to a higher one. So here I have prepared a demo. First of all, we navigate to the OSM GUI and the network service packages. As we can see, we have the initial network service with the user VNFs and also the security network service with the dedicated security services. We go to the network slice template where we can see the extended network slice that has been created automatically from the system manager, as we explained before. And as if we could get inside the information model, we can see the two different network services, the security and the initial slice, to be attached inside the network slice. Also, this extended network slice has been requested for deployment from the system manager to the OSM a few seconds ago. So now we will see it at a waiting state. This is the network slice with the prefix icon. Also here we can see the waiting network services. Now our all deployed, both the slice and the services. Now we are navigate to the OpenStack GUI, where at the background we can see the 4 VNFs of the extended slice. And at the left, you can see the terminals of the user VNFs. At the middle, the security analysis terminal. And at the right, we can see the core components of the security service of py-Edge platform. Here, the security API gateway will receive the request that the extended slice has been instantiated and will inform the security observer. The security observer will take this request and will perform some actions. These actions are to configure the routing rules to the VNFs and also to activate the security analysis on the security analysis service VNF. Now we are waiting for the security observer to finish the job. Now has finished, as we can see, and had informed the security API gateway. Also, we navigate to the SaaS VNF in order to validate if its IPs are the correct one that provided from the OpenStack. Also, we navigate to the VNF1 to make the same validation. As you can see, is the correct one. And also regarding our use case scenario, at the VNF1, we start a simple HTTP server at a specific port. This port is the port that we will attack. Now we navigate to the VNF2. We make the same validation regarding the IPs that are provided by the OpenStack. And we perform a ping command to the VNF1 in order to check if the configuration, if the routing rules are configured properly. Also, we navigate again to the SaaS VNF in order to check the output of the threat detection service that runs periodically every 1 minute. Also, again, to the inside the SaaS VNF, we check the internal services of the SaaS VNF if they are deployed successfully. Here we can see 2 Dockers, the Zeek and FileBit. The Zeek is our traffic analysis tool, while the FileBit is the component that transforms our data from the Zeek and pass it to the support services such as Elasticsearch and Kibana. As you can see, the 2 Dockers are successfully deployed. Now we go again to the VNF2 in order to prepare our attack. We are going to prepare a DDOS TCP SYN attack. For that reason, we use the hpic3 command in order to send thousands of TCP SYN connections to the active port of the VNF1. Also, we spoof and fake our IP, our source IP. Now, we start the attack. And we will stop it. As you can see, a lot of packets have been transmitted. And also on the SaaS side, if you can see, the service, the security analysis service, have efficiently identified the attack, and also it provides an action which is to higher the granularity of the security analysis service. This is our action. Now we go again to the VNF2 in order to perform another attack. We start again the attack, and in a few seconds we stop it. Also, we have transmitted a lot of thousand packets, and also on the SaaS side, we will see that in a few seconds that the SaaS will efficiently analyze the threat. Now, at the last part of our demo, we navigate to the Kibana dashboard. The Kibana dashboard visualize and present many kind of logs. In our case, we want the weird stats, as you can see at the left, the weird stats as a summary of the weird and malicious statistics that obtained from security analysis service in a time interval. Also, these weird statistics, these weird stats are visualized to Kibana as hits, as the green boxes. The hit has a counter number that describes the number of lines of the weird statistics that contains in the analysis of our log files. Also, as you can see, each green box, each hit includes a lot of information. As you can see, each hit has a name, an ID, a timestamp. In our case, the most valuable for us is the name of the weird statistic. As you can observe, the majority of the hits are classified as bad TCP checksums with 1,000 of numbers seen. That's described the DDoS attack we performed before. Also, as you can see, each hit, each green box arrives every 30 seconds, which is the granularity we have set before, because the default one is at 10 minutes. As you can see, every hit arrives every 30 seconds. Now, as you can observe, we have no hits anymore because we have stopped the attack and there is nothing else to predict. So we have some empty boxes. Here we conclude our presentation and also our demo.
Okay, so how do you evaluate the trust of a certain network service? Do you use like behavior-based detection or signature-based detection techniques to find some vulnerabilities within the network service or any threats?
Okay, so what we actually do is not assess whether a slice or not is trusted. What we do is we continuously observe, monitor the traffic patterns that are exchanged between components of the network slice, namely VNFs, and this way, based on a declarative way that the slice tenants have declared that they would like to observe a particular type of security attacks or particular type of suspicious or malicious traffic. Then we translate this automatically to traffic patterns, okay? And we show in real time the analytics, and we also visualize the analytics that contain information about this kind of threats. So it's not like a binary decision of whether or not slices are trusted or not. On the contrary, we have decided to constantly monitor in high granularity all the different traffic patterns and behaviors, so as to throw security notifications and to give a situational awareness to the slice operators. I don't know if that answers the question.
So this traffic analysis for the pattern. This is actually a signature piece. So this means that you will end with a decision like how either to drop the network service, okay, or to still use the network service. I mean,
Correct.
there
Yes.
should be a decision, right?
Correct. So the idea is that, again, in a declarative fashion, the end users can decide which kind of actuation should take place upon the detection event. Let me share a bit. Maybe it's better visible in the information model.
Yeah.
Okay. Can you see my screen now?
Yes.
Okay, so if you see this light blue box here, this is where inside the NST descriptor we declare the automation service that is of type security, which has a name and an ID, etc. So it also includes the security policy. So here we declare a list of different threat types to be detected on a high level, okay, and plus the action to be taken on detection. In today's demo, what we are showing is the zoom in of the monitoring analytics. So it means that once we identify suspicious or weird behavior in the traffic patterns, we increase the granularity of the monitoring, of the sampling, let's say, of the monitoring. But we are also experimenting with different other types of actuation, like, for instance, what you mentioned, to block some particular types of traffic, even to bring down the network service. But the more sophisticated actuation that we're looking into have to do with honeypotting solutions. So what we do is we create a mirror, let's say, of the components of the network slice that are under attack or that are suspected to be under attack, and using techniques for spoofing the sender IP traffic, we have the attackers, or who we suspect to be attackers, believe that they are interacting with the real service, whereas in fact they're interacting with a mirror of the real service, and we are continuously collecting data about their interactions.
Okay, so you mean the decision here is using like multi-objective function, which collects several parameters, not only whether the network slice is trusted or suspicious only, and then the decision is applied later on, right?
Exactly. We can have arbitrarily sophisticated security policies in place. So okay. It's not only, exactly as you said, it's not just a characterization of trusted or not. Actually, in another research item of the same H2020 project in 5GZORRO, we are also working with integrating this solution with the trust management entity, which does exactly some trust management scoring of the different slices and the different services.
Okay,
so
that's great.
This is a valid concept, but what we are showing here is mostly scoped, on the security actuation.
Yeah, from security perspective. Yeah, thank you. I appreciate it.